Will the International Space Station eventually die by fire? Well, since the International Space Station has been in orbit over the Earth for more than 20 years, its time will definitely come. The demise of the space station will also be harsh because, like all of the larger spacecraft, it will burn up in the atmosphere of Earth. Astronauts have lived in the vast orbiting laboratory for exactly 20 years, and their stays there have taught scientists a ton about what it means to step into the chaotic environment of microgravity. According to NASA, building the space station required 42 different launches in all. The structure would be over 900,000 pounds. According to NASA, the structure has the same amount of usable capacity as a 6-bedroom house on Earth and is almost the length of a football field. Christian Maender, director of in-space manufacturing and research for Houston-based company Axiom, which is also preparing to construct its own space station, told Space.com, saying, "We built the largest peacetime engineering project ever, and by building pieces of an overall spacecraft that never actually saw or touched each other until they got to orbit." She further stated that when they first embarked on the ISS, no one had any idea how to construct something like this. It's huge, complex, and essentially unbelievable. However, the life of the space station is limited the moment human intervention ends. The International Space Station is aging, just like the rest of us. In orbit, where the laboratory is always at risk of being impacted by micrometeorites and space debris, and where even the smallest interruption might spell tragedy, this fact presents a unique difficulty. However, to ensure the station's lifespan, NASA and other partner organizations constantly assess its status. Even though their most recent, thorough research only covered the years up to 2028, NASA is now optimistic that the station will continue to function normally through 2030. Even in perfect condition, the International Space Station needs a regular boost of fuel injection from passing spacecraft to maintain its orbit. The lab will eventually collapse if those enhancements are stopped or if something else goes wrong. According to Harvard astronomer Jonathan McDowell, who specializes in detecting objects entering and leaving orbit, basically each cargo ship that comes into the space station, or indeed any ferry ship, usually has extra propellant to some extent. They need a propellant to do the rendezvous, and they occasionally have extra to perform a reboot. The space station will be at the mercy of Earth's gravity and atmosphere if any such fuel deliveries halt. But in the end, what goes up must come down. The choice to retire the station will always be dependent on both engineering and politics due to the station's international role as a cooperation between the United States, Russia, Canada, Japan, and the participating states of the European Space Agency. Although its partner agencies have not yet agreed, NASA has already committed to keeping the station in orbit until 2030. For NASA and Roscosmos, Russia's state space agency, the fate of the space station has always been a concern, but as time has gone on, it has grown more and more prominent in space. NASA described a nominal scenario for the station in which it is gently lowered through the atmosphere by the end of 2030 in a document created in January 2022 outlining procedures for transiting from International Space Station to its anticipated commercial successors. That's because NASA's Skylab station has lost its orbit only a few years before, in 1979. The organization had intended to elevate the station using an early space shuttle voyage. However, the spacecraft was delayed. The 80-ton Skylab was left stranded as solar activity increased, warmed, and expanded Earth's atmosphere, accelerating the facility's demise. Because of this, NASA was unable to target the pieces over remote locations or manage the spacecraft's descent to slow it down and make the pieces smaller. As a result, the spacecraft plummeted out of control on its own. Consequently, pieces of the station were dispersed across Australia, with a sizable oxygen tank being the largest. The episode marked a paradigm shift in how people view how big objects exit orbit. When the space era first began, nobody was concerned. Now, people have gotten more and more risk-averse over the years. Additionally, as spaceflight gets longer, researchers become increasingly concerned about orbital debris, especially the biggest of it. The risk is high if the space station does indeed fall to Earth by itself. The space station is by far the biggest man-made object to have ever circled the Earth, weighing in at around 400 tons. The likelihood that the atmosphere can completely burn away an object decreases with its size. Also, the space station is susceptible to spinning out of control due to its extended solar arrays, which would limit the alternatives available for rescue. So no matter what led to the uncontrolled entry, the consequences would not be nice. However, they wouldn't be as dire as a nuclear catastrophe. Although the debris would be dispersed across a much larger region, it would resemble a plane crash more. In the worst case scenario, I suppose it's 9/11, right? But would be terrible. But not asteroids hit terrible. So how will they manage the re-entry of the space station? Well, at the 2017 International Astronautical Congress, a team of engineers from NASA and Roscosmos presented a study analyzing various disposal strategies. Their research relies on de-orbit procedures performed in 2001 on the Russian space station Mir, which is nearly 3 times heavier than the International Space Station. The basic idea behind the concept, though, is similar to how the space station maintains its altitude during routine operations. The station climbs most frequently when a Russian Progress cargo ship either performs a burn while docked to the station or transfers fuel to the main service module's thrusters to fuel the station's own burn. Progress vehicles would perform the same action in the opposite direction during a controlled de-orbit, decreasing the station's lowest altitude. The service module thrusters could also be employed depending on the particular array of ships at hand. NASA officials estimated that 3 Progress spacecraft would be needed to de-orbit the station in the 2022 transition report, while they're also considering if Northrop Grumman's Cygnus spacecraft could be able to help. The station would be lowered by these precisely scheduled burns only once during its orbit, improving the predictability of the re-entry and enabling management to direct the debris onto the huge, sparsely populated southern Pacific Ocean. The ability of the Earth's atmosphere to cause destruction will determine the rest. Obviously, the tactic has some hazards. The predictability will be lost if something interferes with the burn-off timetable. The 2017 report outlines possibilities for a planned de-orbit as well as in the event of a major disaster on the space station. The groups behind the facility will only have 2 weeks to decide how to proceed if something unexpectedly goes irreparably wrong with the orbiting laboratory. The retirement of the successors to the International Space Station may go more smoothly, though they will still be fiery. For instance, Texas-based Axiom Space intends to launch additional station modules in a few years. As business interest in reaching orbit rises and the ISS gets older, Axiom Space plans to eventually cut ties with the ISS and establish its own independent free-flying orbiting facility. However, Axiom has already contemplated how its facility will terminate after learning from the complex fate of the space station. To give the corporation flexibility in the future, the company plans for its modules to be more truly modular than those on the space station, with the ability to remove and replace segments with ease. Also, the configuration gives each module autonomy over its course. Each module will be designed with its own guidance, navigation and control, as well as its own propulsion capabilities, so they can practically fly alone, and when necessary, they can split off and return through Earth's atmosphere alone. Alright guys, this wraps up our video for today. If you found it interesting, please do well to give it a thumbs up and don't forget to hit the subscribe button as well.